Hi everyone, welcome to Huck Learning for All. So we have been discussing here one of the integral of the form this in our previous videos where m and n are positive integers. So far we have discussed three of the cases. So this is our case 4. So in case 4 actually we are going to discuss if one of the power is 0. For example, if m is 0 but n is non-zero, or n is 0 but m is non-zero, so any one of them is 0 from here. So how to deal in this kind of situation? So for example, if we have an integral of the form sine cube x dx, so you can see that this can be written as sine cube x into cos 0 x dx. Okay, so we can consider this cos to the power 0x as 1, right? So we can pretend that this 0 is actually the even power, because you know that this minus 1 to the power 0 is 1 and 1 to the power 0 is also 1. So we can pretend that one cos x has the power 0, right? And we have the power of sine is cube, which is an odd power. So we can deal this kind of integral as a subcase of 1. So we can deal this one like case 1. So in case 1, what we did, if you remember, we split this sine x dx as in such a way that one of the power of sine x is 1 and the other one should be 1 less degree than this number. So that should be 3 minus 1, which is sine square of x dx, right? And this sine square x can be replaced by the formulation like sine square x plus cos square x equal to 1. So sine square x can be written as 1 minus cos square x. So if you replace this sine square x here as 1 minus cos square of x, and this sine x is still there, so you can use the substitution to get rid of this cos x, because the derivative of cos x is sine x next to it. So you can substitute u equal to cos x here. So this du by dx would be minus sine x. Okay, and further we can, let's say this is equation number 1, and we can write down this du over dx times dx equal to sine x times dx, and we can shift this minus sign on the other side because we are looking for sine x dx as well. So we can say this and this together as equation number 2. So when we sum in the value of cos x in terms of u, so the given integral in 1 would be of the form of 1 minus cos square x, which is now u square, and this sine x dx can be replaced as minus du by dx into dx, and we can take this negative sign outside of integral, so we have 1 minus u square and du. Okay, and if you like, you can split the integral, and you would have u square du, and once you integrate that, you would get u minus u cubed by 3 and plus some integrating constant, and you can substitute back the value of u, which is cos x. So you would have minus cos x minus cos cube x by 3 plus c, and if you like, you can multiply this negative inside. So that's the integral of sine cube x dx, right? So that's the way to deal these kind of integrals. So you can use the technique what we discussed in case 1, right, easily. So now we are going to discuss another case when you have an integral of the form with even power, say cos 4x dx. Okay, so the crunch idea for the even power is same as we discussed in case 3. So if you remember that we explained to you that you have to linearize this function as much as possible by using the double angle formulas. So what we are going to do here, we are going to use the double angle formula for cos squared x, which is equal to 1 plus cos 2x by 2. Okay, so that's our case 3. So we are going to use this one by case 3 by using this double angle formula. Okay, so this integral cos square x to the power 2 dx can be rewritten as by using this double angle formula as 1 plus cos 2x by 2 whole square, and that would give you 1 plus cos 2x whole square by 4 dx, and you can expand this expression with a plus b whole square. Maybe you may remember, which is a square plus 2ab plus b square. So this is your a and this term is b. Maybe if you like, you can keep this 1 by 4 outside, the quarter outside. And when you expand by using this formulation, so you would get 1 plus 2 cos 2x and plus cos square 2x dx. Okay, so again you can see that you have still an even power over here. This one is now linearized because you have the power 1 here, so it's not a big issue now, but this one is still an issue. So to deal with that one, because it's an even power, so you can use the same double angle formula, but instead, if you remember that if you are going to use this double angle formula, so if it is angle x on the left side, so that's going to be double here. So in this case, if we have to write down the formula for cos squared 2x, so we have the same formula, but whatever the angle you are going to use here, that's going to be double here. Okay, so we are going to again linearize this cos squared 2x because it is an even power. So 1 plus 2 cos 2x, and you are using this double angle formula over here. That would give you 1 plus cos 4x by 2 dx, and you can simplify as much as possible. So maybe we can write down 1 plus 2 cos 2x plus 1 by 2 plus cos 4x by 2 dx, and you can integrate individual terms. So the first term would give you x, and the integral of cos is sine 2x and divide by 2, and the integral of 1 by 2 is 1 by 2x. You could combine these two terms earlier, but we can combine now. And here the integral of cos 4x is again sine 4x by 4, and plus integrating constant. If you like, you can combine these two terms together, the x terms. That would give you 3x by 2 plus sine 2x and plus sine 4x by 8 plus c. You multiply this 1 by 4 inside, so that would give you 3 by 8x plus 1 by 4 sine 2x and plus 1 by 32 sine 4x plus c. So that's the integral for our cos 4x dx. Okay, so hopefully that you understand the way what we have described here. So thank you very much to watch this video. See you in the next video. Bye.